Let's talk about a simple problem about calculating angular momentum and torque. So we have a turbine fan in a jet engine with moment of inertia of 2.5 kilograms meters per second squared, meters squared, about its axis of rotation. So as the turbine starts up, the angular velocity is given by omega z, 40 radians per second to the third power times t squared. So it's a function of time. The first question is to find the fan's angular momentum as a function of time and what is its value at time t equal to 3 seconds. The second question is to find the net torque on the fan as a function of time and what is its value at t equal to 3 seconds. So for the first part of the problem, I'm going to use the relationship between the angular momentum, moment of inertia, and angular velocity, namely that L is equal to I times omega. And I'm keeping the subscripts provided in the problem. For the second part of the problem, I'm going to use the relationship between torque and the time derivative of the angular momentum, namely that the net torque is equal to ddt of the angular momentum of the rigid body. So let's start with part A. So I know that the angular momentum Lz is equal to the product of the moment of inertia and the angular velocity omega z. I know the values of both quantities, so that is 2.5 kilograms meters squared times 40 radians per second to the third power times t squared, which gives me 100 kilograms meters squared per second to the third power times t squared. So at t equal 3 seconds, Lz is equal to 100 kilograms meters squared per second to the third power times 3 seconds to the second power, or Lz is equal to 900 kilograms meters squared per second. And that is the value of the angular momentum at t equal 3 seconds for the turbine fan. To calculate the torque, tau z, I take the time derivative of Lz, so that is 100 kilograms meters squared per second to the third power dt of t squared. And so this will give me 100 kilograms meters squared per second to the third power times 2t. Or that is equal to 200 kilograms meters to the second power divided by seconds to the third power times t. So at t equal to 3 seconds, tau z is equal to 200 kilograms meters squared per second to the third power times 3 seconds, or this is 600 kilograms meters squared per second squared, or in other words, 600 Newton meters presented in standard units for torque.